MCV4U1, Chapter 3, Session 3. In this session, we are going to work on Section 3.1 of the textbook, Higher Derivatives, Velocity and Acceleration. Derivatives arise in steady of motion. The velocity of a car is rate of change of the displacement at a specific point in time, which means velocity is derivative of the position function, and acceleration is the rate of change of velocity at an instant, which means acceleration is derivative of velocity, which is derivative of position function. Derivative of derivative is called second derivative. Derivative of y equals f of x is denoted by y double prime or f double prime of x. If you use Leibniz notation, you have d2y dx2. The nth derivative of a function is denoted by this notation, or dny dxn. To find the second derivative, you find derivative and then take the derivative of derivative. For example, the derivative of y equals 2x3 minus 5x2 is 6x2 minus 10x. The derivative of 6x2 minus 10x, which is second derivative of the function, is 12x minus 10. Example 1. Find the second derivative of f of x equals x over 1 plus x at x equals 1. The author of the book converted the given function to x times 1 plus x to the power of negative 1 and took the first derivative. We are using the quotient rule. Derivative of f over g is f prime g minus g prime f over g to the power of 2. Derivative of numerator is 1 times denominator, which is 1 times 1 plus x. It is 1 plus x. Derivative of denominator is 1 times x, and if we simplify it, x and x cancel. Derivative is 1 over 1 plus x2, which is 1 plus x to the power of negative 2. This is f prime of x. The second derivative is derivative of this function. We use the power rule for a function. Minus 2 times 1, which is multiplication of the exponent and coefficient. 1 plus x to the power of negative 3. Minus 2 minus 1 is negative 3. And derivative of the expression inside the bracket. Derivative of 1 plus x, which is 1. Therefore, the second derivative is negative 2 over 1 plus x to the power of 3. If we plug 1, we have negative 2 over 8, which is negative 1 over 4. As we discussed, velocity is the derivative of position function with respect to t, and acceleration is the second derivative with respect to t. T is time. The absolute value of velocity is speed. The unit of velocity is meters per second, and the unit of acceleration is meters per second squared if the position measured in meters and the time is measured in second. The sign in velocity shows the direction. If vt is greater than 0, object is moving to the right, positive direction, and when vt is less than 0, it's moving to negative direction, or left if object is moving horizontally. Positive when it is moving vertically is upward, and negative is downward. Next example. An object is moving along a straight line. Its position st to the right of a fixed point is given by this graph. when is the object is moving to the right and when it is moving to the left, and when it is at rest. The object is at rest when derivative is 0. Derivative is 0 at 2 and 6, when the tangent line is horizontal. The object is moving to the positive direction, or right, when the slope of the tangent line is positive. Between 0 and 2, at any point, the slope of the tangent line is positive, therefore the object is moving to the right when t is between 0 and 2. Between 2 and 6, the slope of the tangent line at any point is negative. That means object is moving to the left when t is between 0 and 6. Next example. The position of an object moving on a line is given by s at t equals 62 minus t3 when t is greater or equal than 0. Where s is in meters and t is in seconds, A, determine the velocity and acceleration of the object. Velocity is first derivative, 12t minus 3t2. Acceleration is second derivative, which is derivative of 12t minus 3t2, 12 minus 6t. When t is 0, velocity is 12 meters per second and acceleration is 0 meters per second squared. Part B, at what time is the object at rest? Object is at rest when velocity is 0. Velocity is 12t minus 3t2. If we set it to 0 and use factoring method, t is 0 or 4. Therefore, the object is at rest at t equals 0 and at t equals 4 seconds. Part C, in which direction is object moving at t equals 5? Velocity at 5 is negative 15. Negative indicates the object is moving to the left or negative direction. Part D, when is the object moving in a positive direction? Object is moving in the positive direction when Vt is greater than 0. If we draw the interval or sign chart for Vt, it is 0 at 0 or 4. Between 0 and 4 it is positive, and after 4 it is negative. This means the object is moving in positive direction when t is between 0 or 4. In the textbook, draw the graph of velocity time, which is a parabola downward. Between 0 and 4, velocity is positive. That means object is moving to the right. Either graphing method or using the interval chart, we get the same answer. The last part, part E, when is the object returned to its initial position? We know initial position is 0, s at 0 is 0. Therefore, we set s at t equal to 0, and we see at t equals 0 or 6, object is at 0, which is the initial point. So the object returns to its initial point at t equals 6, where it was at t equals 0. Next question, next example. Discuss the motion of an object moving on a horizontal line if the position is given by s at t equals t2 minus 10t when t is between 0 and 12. S is in meters and t is in seconds. Include the initial velocity, final velocity, and any acceleration in your discussion. It's a second degree function. Velocity is 2t minus 10, and acceleration is 2. Acceleration is constant when t is between 0 and 12, and it is 2. Initial velocity is velocity at t equals 0, which is velocity at 0 is 2 times 0 minus 10. It is minus 10 meters per second. And velocity at t equals 12 is 24 minus 10, which is 14 meters per second. At t equals 5, velocity is 0, which means object is at rest. If we look at the graph of velocity time, between 0 and 4 velocity is negative, between 4 and 12 velocity is positive, between 0 and 5 velocity is negative. So between 0 and 5 object is moving in negative direction, 5 and 12 in positive direction, and as we said, velocity at the beginning is negative 10, velocity at the end is 14 meters per second, and acceleration is constant and it's always 2. If we look at the graph, between 0 and 5 object is moving to the left. At 5 the position is negative 25. At 0 the position is 0, and after that it's moving to the right. At t equals 12, s is 24. The total distance is 25 plus 24. It goes 25 to the left and 24, and 24 it goes back to 24, which is 24 plus 25 plus 49 total distance. Next example, example 5. A baseball is hit vertically upward. The position of the function in meters is s at t equals negative 5t2 plus 30t plus 1, where t is in second and s is in meters. Determine the maximum height reached by the ball. We know at maximum height, velocity is 0. Velocity is minus 10 plus 30. If we set it to 0, t is 3. So after 3 seconds, the object is reaching the maximum height, which is 46 meters. Determine the velocity of the ball when it is caught 1 meters above the ground. 1 meters above the ground means s is 1. We set s to 1 and we solve the equation for t. T is 0 or 6 at the beginning or after 6 seconds. We find velocity when t is 0 and 6. Velocity is minus 10t plus 30. At t equals 0 it is 30. At t equals 6 it is negative 30. As you know, the sign of velocity shows the direction. If you look at the graph of velocity time, we see after 1 and after 5 seconds, the position of the ball is (26 meters). In summary, the derivative of derivative is called second derivative. The derivative of second derivative is called third derivative. Velocity is derivative of position, ds dt, and acceleration is derivative of velocity, which is second derivative. Negative velocity indicates that the object is moving in a negative direction, left or down at time t. Positive velocity indicates the object is moving to the right or up, positive direction. Zero velocity, or s prime of t equals 0, indicates the object is stationary, and that a possible change in direction may occur. The notations: f double prime, d2y dx2. Negative acceleration indicates the velocity is decreasing. The rate of change of velocity is negative. Positive direction means velocity is increasing. Zero acceleration means velocity is constant. An object is accelerating or speeding up when its velocity and acceleration have the same sign. Velocity positive, acceleration positive means object is moving to the right and speeding up. velocity negative, acceleration negative means object is moving in negative direction and speeding up. When the object is decelerating, velocity and acceleration are in opposite sign. One of them is positive, the other one is negative. The speed is absolute value of velocity. To understand the question in the concept in this section, in next session we are going to solve some questions. Question number 4, part A, which is related to a graph. Question number 8 and question number 11. Thanks for watching.